So we want all those things in a crypto system. That sounds great. So let's look at these intersection points. Where can quantum and classical coexist and meet each other? And so there are integrations at different abstraction layers that we can consider. And now let's look at the network architecture level. So there are many architectural considerations to look at here. So topology is one. What does your network topology look like? What's your footprint of data centers or edge devices? What portions of your network actually go through free space or satellite communication versus fiber optic terrestrial networks? What do you do for key management, and what policies do you want to install for your organization? That may very well depend on the kind of data that is traversing your network, the sensitivity of it, how long it needs to be secret for, things like that. Gateway functions, right? So at those transition points between say a quantum-enabled link and a purely classical link, these gateway nodes will be really critical for maintaining that notion of security, across that boundary. And so typically, we see these hybrid architectures at the network level looking like something like this on the right, where you have the QKD or advanced secure networking at the critical kind of backbones of your network, and these are the the high data rate links of your network that are exchanging the most amount of sensitive data, right? And so you really want that advanced level of security for those links. These are infrastructure that usually is connected by fiber optic channels, so it makes it a great kind of use case for the quantum approaches. But at the edge, right, with the advent of IoT and edge devices and wireless, right, it's going to be a lot harder to roll out some of these quantum solutions to the edge. And so typically you'll have PQC really playing more of a driving role at the edge of your network and in the last mile.